All right, moving on to warm up. 7.6, we've got 3 focus graphs today. First one is rational, second one's exponential, third one's log, okay? Exponentials and logs should be pretty fresh in our mind. This was the last thing that we learned before we started this unit, okay? So having said that, I'm not going to spend a whole lot of time on those. We're going to do one of each, but that's going to be it. The rationals, though, we haven't done those for a hot minute, okay? So that's going to be really our main focus graph today, but we are going to talk about all these. So first things first, when we see the word rational, when we think rational, what is a ration? It's another word for it. Starts with an F. Fraction, yes, fraction, fraction, fraction. If you see a fraction on an Algebra 2 EOC, it's going to be a rational. It is going to be a rational. Okay? Cool. Now we got to think about what these look like. Okay? They look kind of weird. I would say out of all the things that we've graphed, personally, I find these to be probably the most challenging. Okay? But again, we get to use Desmos on this EOC, so it should be a lot easier than when we had to do it by hand. But if we think back to those fractions, think to what these look like. Do these have asymptotes? They sure do, okay? So these are always going to have a vertical asymptote. Okay? We do that by setting the denominator equal to 0. Denominator equals 0. That's your vertical asymptote. You're always going to have that. We always had these. Okay? Then we had the horizontal asymptote. And when we think horizontal, we think house. Remember this? Yeah? Okay. So this depended on the powers. Depends on powers. Okay? So just a little flashback here. If we're talking about a house, okay, so we're going to compare the numerator to the second story of our house, denominator to the main story of our house, okay? So if the numerator was bigger, so the second story was bigger than the first story, we said house crashed down, there was no house, meaning there was no asymptote, okay? If they were the same, so the first story was the same as the second story, then we had to go to what Liz Hilly calls the front yard, right, which are the leading coefficients. So for instance, if both powers were x squared and one of them was 3x squared over 2x squared, our asymptote would be 3 over 2, okay? And then last but not least, if the first story, so the numerator, was smaller than the second story, we said that's pretty typical, that's 0 fun, right? So the asymptote was 0. You with me on that? Okay, just another little way to remember it. But again, this just depended on the powers that you had for the numerator denominator, okay? So we did have asymptotes. Another thing that we could have, we loved them. Yeah, the holes, right? They were kind of difficult. So if we had a common factor, meaning if we were able to factor from the beginning and cross something off, then we had a hole or an undefined point, okay? And then for the domain and range, we also loved this. Just kidding, it was kind of a pain. But for domain and range, we had to watch out for all of those asymptotes and holes, right? Because the asymptotes we said were like walls, and the holes were just big holes in the wall, okay? So we had to make sure we went around them. So that's one more thing I do want you to write. So watch out for asymptotes and holes in domain and range. Okay. Coming back to us a little bit. As far as what these look like, and you're welcome to write this down if you want to, these were kind of like the opposite quadrant graphs we talked about, right? So we'd have quadrant 1 and 3 or 2 and 4, depending on what this thing did. So if you want to write that down, you can too. Okay, so moving on from that, we're going to go ahead and jump to exponentials. Again, these should be pretty fresh in our mind. What did an exponential look like? Huh? I can't hear you. You're mumbling.
Yeah, I know.
TJ actually had a really good way of describing this, if he can remember. He said that these ramped up or ramped down. You remember saying that? Yeah, I use that in all my classes now because I think it's great, okay? These ramp up or they ramp down. Think of these as a ramp. Okay, so if we think of these as a ramp, what kind of asymptote did these have? Horizontal, yep, horizontal asymptote, which is y equals whatever number. The domain on these, it was always what? You got it, negative infinity, positive infinity. We're on left and right forever. And then the range on these, it was not negative infinity, positive infinity. But instead, yep, negative infinity to k or k to infinity. Or if you want to, instead of writing k, you could write the horizontal asymptote, right? So start at that asymptote and go to infinity if it's exponential growth. If it's decay, though, we're starting at negative infinity and we're ending at that asymptote. So k or ha, whatever you want to put there. Okay? Cool. I like it. And last but not least, we got logarithmic. Okay? These didn't ramp up or down, but they ramped kind of to the side, right? And really, these always ramped to the right, because remember, we couldn't go left on these. Why couldn't we go left? Yep, can't take the log of a negative. That's always undefined. So these kind of ramp to the right. They could be like this, right? Or like this. What kind of asymptote did they have? Vertical. Good. Vertical asymptote. The domain on these. We didn't go left or right forever, right? Because we didn't even start until the asymptote. So if we want to call that k, we're welcome to. K to infinity was always going to be that domain. Or if you want to write vertical asymptote to infinity, whichever, it's going to be that same number. Okay? And then last but not least, the range. Negative infinity, positive infinity, you got it. These go up and down forever. So exponentials and logarithmics, they are inverses, right? If I take an exponential and I turn it on its side, it becomes a logarithmic. Okay? Okay, enough vocab for the day. So, we are going to start with example 1. I want you to go ahead, put it in Desmos, put it on the graph, answer as many of the blanks as you can. Okay, I'm going to give you about 4 minutes on each of these. So after the 4 minutes, we'll go over this, and then we'll go to the next one. So go ahead and get started. Your graph should look like something like this. Well, not something like this, but it should look like this. Mine's not beautiful, but I have everything where it needs to be. Okay? Questions on how I got that? Did anybody not get that graph when they typed it in? Big thing on this is just typing it in right, okay? How did you get those asymptotes, Mrs. Bellman? So how I did that was I zoomed in on that graph, okay? I could see that there was an evident vertical asymptote and an evident horizontal asymptote that neither of those lines were touching. Okay, I could draw on my, or take my finger and I could drag those points, and I could see that if I, up there on the one that's in the first quadrant, if I dragged up, it was getting really, really close, that x value, to 3. It was like 3.2 and then 3.1, and then it just kept getting closer. It's never actually going to get to 3, okay, but it's going to get pretty darn close. Same thing with the other one. If I kept dragging on that side of the x value, it's going to get to like 2.8 and then 2.9. It's going to get really close to 3. Okay, and then same thing with the y value. Dragging up and down on those, it's going to get really close to that 2, but it's never going to be 2. Okay, so that is why those are the asymptotes. So if I were to write those asymptotes as an equation, what would the vertical one be? X equals 3, good, because again, it's the x-axis. You put a point on 3, that's a vertical line. VUX was that acronym we learned, a VUX, vertical, x equals, right? Undefined slope. Okay. Horizontal asymptote, how would I write that equation? Y equals 2. That was the Chips Ahoy, right? HOY, horizontal lines had a 0 slope, Y equals, okay? So if you need to write those acronyms down, please do. Did this thing have any holes? No, okay? And I can look at this and tell from the beginning that I can't factor that. I can't do anything with that, okay? So that is not going to have a hole. So I'm going to put none there. Okay, we'll start with domain. So from the left to the right. I have no holes to watch out for, but I do have to watch out for the asymptote. So one thing too that helped some students last class, if you put negative infinity out here, positive infinity out here, okay, so we're starting at negative infinity. What wall are we going to run into? 3, good. And know that the vertical asymptote, right, that's x equals. Domain is all about x values, okay? So we're never going to use the horizontal asymptote in the domain. It's only going to be the vertical. So then we pick back up on the other side of that wall, which is still 3 to what? Infinity. And notice I didn't use any brackets on that, right? Because it can't equal 3. It's an asymptote. That's why we use parentheses, okay? So knowing that, okay, knowing that range is going to work very similar, what should we put for the range? To 2, yep. Perfect. So using that horizontal asymptote. Negative infinity to 2, union with 2 to infinity. Perfect. Limits, okay, again, not going to be on the EOC, so don't worry about them if they still confuse you a little bit. But as x approaches both the left and the right, y is actually going to stop at that horizontal asymptote. Or it's going to approach that horizontal asymptote. So that was 2. Max or min, okay, don't get confused on these. Max or min. Do these ever change direction, or are they always going in one direction? Meaning, are they always increasing or always decreasing? Yeah, it's always going in one on these. So a rational is never going to have a max or a min. There's never going to be a change in direction because you're either going to have an increasing interval or a decreasing interval. So if I look at this one and I follow these arrows from the left to the right, because that's what we always do. Okay, so I'm going to start here at the left and trace this thing. Am I going up or down? Down on both of them, right? So on the decreasing interval, what would I write? Yeah, the domain. Always the domain. Anytime you're dealing with intervals, you're only working with domain. Don't you ever write the range on there. It is never going to work. Okay, so we said we're decreasing. We don't have an increasing interval. X and Y intercepts. We should have been able to zoom in on these. What was the x-intercept? Perfect. And the y-intercept? 0.6? 0.16? 1.6. I see what you mean. I can't hear today. Okay, good. That makes more sense. Cool. So that's what we got. Any questions on that? Do we feel confident? Okay. Number 2, another 4 minutes. Okay. Be really careful on this one because this one's going to have something that the other one didn't. Ooh. Here is the graph we should have gotten. Okay. What you're probably wondering is, what the heck, Miss Gellman, how did you find that hole there? Okay. If you are really good with Desmos, okay, and you're able to drag that line, okay, and if you were able to just happen to come across that point, you would have. So Desmos does tell you the holes. So if you go drag that graph in the third quadrant, if you go and you take it to -4, it should say -4 comma UND, which means undefined, okay, which means that that is a hole point, okay? If you were not able to find that, okay, because again, it does kind of take some strategy and just dragging along that line and making sure you go slow enough to where you're going to see it pop up. How could we find a common factor just from the equation? How did we do that before? Do the math, right? Factor it, okay? So x plus 4, and then on the bottom we just do x method, right? And it would end up getting x plus 4, x plus 2. Whoa, what's the common factor going to be? X plus 4, and if you remember, we set that equal to 0, right? So this would be negative 4, which tells me that's going to be the x value of that whole. So if I know that, then I can just go drag that thing to negative 4 and make sure that it is indeed undefined, and it is, okay? And it's actually undefined at negative 0.5 as the y value, okay? And you know that because if you go a little bit above it or a little bit below it, it's going to be the numbers right next to that, okay? Questions on that? Anybody not get this? Okay, cool. So, and now what we have then, we'll start with the domain, okay? So from the left to the right, where are we starting? We always start with negative infinity, okay? And then we got to pay attention to, are we going to come to the whole first or to the wall first? The whole, and what x value is that? Negative 4, because again, this is x values, it's domain. Unioned with, pick right back up where you left off, negative 4, and now what am I going to? Negative 2, unioned with, perfect, negative 2 to infinity. Raise your hand if you got that one. Cool, thank you, perfect. Okay, the range is going to work very, very similar. Help me out. Negative infinity. Negative 0.5, good. That's what we're going to stop at first. Unioned with 2, 0, and then last but not least, 0 to infinity. Good. Asymptotes. The vertical asymptote was what? X equals negative 2. And the horizontal asymptote. Perfect. Limit. So as x goes left and right, it's going to be approaching that horizontal asymptote again. Max or min, are we going to have them? No. Is this increasing or decreasing? Decreasing. Again, if we trace these arrows from the left to the right, we can see down and down, okay? So no increasing interval. What's the decreasing interval? The domain. Got to copy that big long thing down again. X-intercept. Do we have any? Why? Yep, if the x-axis is an asymptote, we can't do that. What about the y-intercept? 0, 0.5. I like it. Good. How'd we do on that? Good? Okay. Last but not least, we've got 2 logarithms and 1 exponential. These should go pretty quick, okay? I'm going to give you about 5 minutes to do... Actually not. Let's do 3 minutes on number 3. We'll go over it. 3 minutes on number 4. 3 minutes on number 5. Okay? We'll be done in not too much time. One thing too, guys, that I did forget to mention, if you don't want to have to use that change of base formula when you go to type this in, Desmos actually has a button, and we will have it on the EOC as well. It looks like this. Log with a little A right there. So if you're able to find that button, it's gonna, after you hit that button, it'll drop you down to the A, which is gonna be where you type the base. So in this case, that's where you would put the 2, okay? And then make sure you use that arrow to get out of that, and then put your A value in the parentheses, and then +1, okay? So again, use that button right there on Desmos. Okay, number 3, you should have a graph that looks like this. Raise your hand if you got that graph. Gracias. Awesome. Anybody confused on how I got that graph? It's okay if you are. Okay, cool. Domain on this is what? 3 to infinity. Should I put a bracket on the 3? No, because it's not equal to 3. Yep. Range. Perfect. Asymptotes? For which one? Horizontal one? No. Whole? No. Limits as x goes, as x goes from to the left, it approaches 3. Y is approaching negative infinity. It's going down. And then as x goes to infinity, y is going to infinity as well. Again, don't have to know those, but it's good to write them down. Max or min? Neither. Why neither? It's going in one direction. It's either increasing or it's decreasing. It's not doing both. If it's not doing both, you don't have a max or a min. Okay? Increasing, decreasing. Increasing from left to right. If I trace this thing, I'm going up. Okay? So what do I write on the increasing line? The domain. Why not the range? Because you just don't do that. Yep, we just don't do that. And then the x-intercept. 3.5 comma 0. And then what about the y-intercept? Why? Yep, it's never going to go left. Okay, cool. 3 minutes. Go ahead and start on number 4. Okay, just because this one's very similar to the last one, we're going to go ahead and go over it. This is the graph you should have down. We all agree with this graph? Okay, domain on this one. Range. Asymptote. 1 or -1? Yep. Horizontal asymptote. None. Whole. None. Okay. Limit. So as x goes to -1, y is going down forever. And as x goes to infinity, y is going up forever. Okay. Max or min? Neither. Increasing or decreasing? So what do I write on there? And x-intercept? Y-intercept. That one was pretty easy. Okay, cool. Any questions on that? Last one. What type is this, just by looking at it? Exponential. Good. Okay, 3 minutes. Go ahead and do this one, and then we'll be done with notes for the day. Good deal. So sometimes whenever you're going to type this into Desmos, it won't let you type this whole thing in as the exponent, so you need to put it in parentheses, okay? So you'll type in the -2, 3, you'll hit that A to the B power button, and put a parenthesis for x plus 4, and then close it and do your +2. Good question. Should look something like this, okay? If yours does not look like this, if it happens to be ramping up, what that means is that you did not type in this negative in the front, okay? So make sure we pay attention to everything. We type everything in, okay? Would you call this exponential growth or decay? Decay, good. The domain on this. Negative infinity, infinity, up, left and right forever. The range. Negative infinity to 2, because that's where it's stopping, good. The vertical asymptote isn't 1. Horizontal asymptote, y equals 2, good. Poles, no. Limits, as x goes left, it looks like y is stopping at, or approaching 2, and as x goes to the right, y is going down forever. Max or min? Neither. Increasing or decreasing? What do you write there? X-intercept? Y-intercept? 0, negative what? 116? 160. Okay. Probably had to scroll pretty far for that, didn't you? But we're able to. Okay. Questions before we get going on the homework? Feel confident? What's our confidence level on this now compared to what it used to be?
Blue.
Okay. Good. Did you say blue?
Yeah.
Is that like a happy color?
Yeah.
Okay. Cool. All right, that's it.